Hello everyone, I'm Takao Sato from Japan. In this talk, I'd like to talk about our recent published work related to hydrogen chloride abundance at the cloud top of Venus. So hydrogen chloride is a dominant source of hydrogen and chlorine radicals in the middle atmosphere via the photolysis of HCl. And chlorine catalytic reactions in the middle atmosphere is considered a critical process for the oxidations of photochemically produced CO to CO2. So chlorine chemistry contributes to the stability of the CO2 atmosphere. So as shown in this figure, after the success of Venus Express observations, an inconsistency issue, an issue about HCl abundance came up. So the vertical profiles of HCl derived from solar occultation measurements with solar instrument were inconsistent with the results using ground-based measurements and photochemical model simulations. For example, at the cloud top altitude, nearly one order of magnitude difference exists. So in this work, in order to investigate this inconsistency issue, we re-examined HCl abundance at the dayside cloud top Venus using newly obtained ground-based high-resolution infrared spectra. Okay, so we used a cross-dispersed high-resolution HCl spectrograph named iShell mounted on IRTF, and we selected the LP2 mode, and its resolving power is approximately 80,000 when we use the narrowest slit. And we performed daytime observations in 2018 and 2020. And we selected these observation period because large Doppler shift values enable us to separate the Venusian lines from terrestrial ones as much as possible. So the bottom figure shows slit positions on the Venusian disk in 2018 and 2020. And the slit was set in parallel with the north-south axis of Venus. The data reduction was processed using the SPECS tool optimized for iShell data. And at this stage, neither flux calibration nor removal of the Braze function of HCl grating was performed. Actually, absolute flux calibration is not necessary for our purpose because measuring HCl abundance is possible from relative intensities of the line depths with respect to nearby continent. And the Braze function of HCl grating was considered in the model explained in the next slide. And for retrieving HCl abundance, we selected two different wavelength ranges named order of 144 and order 142. So each spectral order, there are two major hydrogen chloride isotopic groups and CO2 isotopic groups. And the CO2 lines are necessary to determine the probing altitude of HCl abundance. So we used CO2 lines for determining the cloud top altitude. And these figures show the examples of the reduced spectra in order 144 in left and 142 for right. And in order 144, hydrogen chloride 37 line absorption merges with nearby CO2 lines. And the same holds true for hydrogen chloride 35 in order 142. So we didn't use HCl lines for, we didn't use the result derived from these two HCl lines. So the results described later were based on hydrogen chloride 35 in order 144 and hydrogen chloride 37 in order 142. So let me explain how to make a simulated spectra in this slide. So solar and thermal radiance absorbed and scattered by the Venusian atmosphere is attenuated by the Earth's atmosphere and is finally detected by the instrument. So observed count rate at ice wavelength channel can be written by these equations. In our model, we fix the vertical profiles of temperature, gases, and clouds because vertical information cannot be retrieved from this kind of observation. So instead of this, we introduced altitude-independent factors. We called them F factors, which were used to adjust the initial profile to reproduce the observed spectrum. So we retrieved 9 free parameters for each reduced spectrum, 3 parameters for Venus, 3 F factors for cloud top altitude, and 2 major HCl isotopologies, and 2 parameters for Earth, and for coefficients that represent the Braze function of the instrument. So HCl was assumed to have a vertically constant profile with 0.5 ppm as the initial value, and the initial fractional abundance of HCl was set to the terrestrial ones. For temperature and pressure, 2 profiles were taken from Baira, and for clouds, 2 profiles were taken from House et al. And Sato et al. And for calculating the radiance from Venus, we used the line-by-line adding doubling method for considering the multiple scattering. And for Earth transmittance, we used another radiative transfer algorithm named LBL-RTM under the assumption of a clear atmosphere. In the retrieval model, we prepared a total of 8 scenarios as shown here. To evaluate uncertainty associated with the assumptions of forward model parameters or differences in the retrieval approach. So for each scenario, the best fit model was searched with the Marquardt algorithm. Okay, so let's move on to the result. These figures show a comparison of a comparison of spectra between observation and the best fit model. The left is for order 144 and the right is order 142. The best fit model was obtained individually from each order spectrum, and for all data set in 2018 and 2020, almost all spectral features can be was reproduced by our model simulations. Okay, we will show you the results of cloud top altitude. And cloud top altitude in this study, cloud top altitude was defined as the altitude of unit air's optical depths at 1 micrometer. And these CO2 lines were used for cloud top altitude retrieval. And the left figure is latitudinal variation of cloud top altitude in 2018 and 2020. And the right figure is the local time dependence in the region equator world of plus minus 30 degrees. And different color denotes the observation date, and different symbol is retrieval result derived from the different spectral order. And the gray shaded area indicates the result using the Akatsuki IR2 data. So the first, we can say the results were robust because we didn't see any significant difference between the 2 different spectral orders. And the cloud tops had an equatorially symmetric structure, and the average altitude was 70.8 kilometers in the region equator world of plus minus 30 degrees, and the cloud top decreased toward the higher latitude. And these qualitative characteristics support the previous studies that analyze spacecraft data. Okay. And the next is the results, hydrogen chloride abundance. The retrieved hydrogen chloride abundance was calculated by this equation. And the left figure is latitudinal variation in the total volume mixing ratio in 2018 and 2020. And the different color denotes the observation date. And as you can see, HCl showed no significant latitudinal difference, and the average abundance was 0.379 ppm. And so our results support the previous ground-based results by Krasnopolsky and Sander and Clancy. And the right figure is latitudinal variation in the hydrogen chloride 35 over hydrogen chloride 37 abundance ratio. And the average value in the range of plus minus 70 degrees is 3.01. And this value was consistent with the terrestrial one. Okay. So Sato and Clancy conducted the ground-based sublimate measurements. And in the case of nadir-looking infrared observations, we need to assume the temperature profile as a priori information. But in the case of nadir-looking sub-millimeter observations, temperature profile can be retrieved from carbon monoxide lines. And Sato and Clancy retrieved the temperature profile from CO lines, and they used these results for retrieving the HCl abundance. And the sub-millimeter observation do not require, in addition to this, sub-millimeter observation do not require any assumptions regarding clouds, because clouds are transparent in the sub-millimeter ranges. So we can state the consistent results led by ground-based infrared and sub-millimeter measurements validate their retrieval results that are different from each other. And the right figure shows hydrogen chloride absorption features with the best fit model and the model using the original SOA profile. And the left is for sub-millimeter case, and the right is for infrared case. And as you can see, the original SOA profile, original SOA vertical profile cannot reproduce HC absorption features at all. And Shao et al. 2022 investigated the local time variability of HCl with 3D GCM in combination with the 2D chemical transport model. And according to their result, at 74.7 kilometer, HCl pre-mixing ratio was 0.38 ppm with very weak local time dependence. And our results were also consistent with the model simulations. Okay, here is the conclusions. And the most important thing is our new ground-based result for HCl is consistent with the previous ground-based measurements by Krasnopolsky and Sato and Clancy, and the model simulations by Shao et al. 2022. And our paper was published in ICARS, so I'm happy if you check our recent paper. That's all. Thank you very much.